Tuendelee na kipindi chetu, na hii ni chemical equilibrium. Kwa watu ambao tulikuwa wote kwenye vipindi vilivyopita, tumeangalia kuhusu reaction quotient na worked examples mbalimbali. Kwa hiyo kipindi hicho naangalia factors affecting chemical equilibrium. Usahau kusubscribe channel na kushare the link, sababu hii channel pia sasa vipindi vya physics, advanced biology pamoja na advanced mathematics vitakuwa vinarushwa kwenye channel hii. Tuanze sasa kwamba kwenye factor affecting chemical equilibrium, by definition tunasema this refer to any external force which when is introduced into a system that has already established equilibrium tend to alter equilibrium system in order to proceed more towards one direction than in opposite direction. So this is the definition of factors affecting chemical equilibrium. Any external force which when applied to the system which has already established the equilibrium tend to alter the equilibrium system in order to proceed more towards one direction than in opposite direction. Kwa hiyo kama ambavyo tunajua kwamba equilibrium reaction the reversible reaction. Now assuming our equilibrium reaction looks like this. Now from here what we can say is that we may apply any factor which can alter the position of chemical equilibrium. Maana yake inaweza kusababisha equilibrium ishift kwenda forward au kwenda backward. Na hiyo factor sasa, yani kile kitu kinachoweza kubadilisha position of chemical equilibrium ndio tunakiita nini? Factor affecting chemical equilibrium. Now, chemical equilibrium is the very delicate system that represents a perfect balance between forward and reverse reaction. Very delicate. You may alter it anytime. A small disturbance in equilibrium may shift the equilibrium position either to the right, forming more product, or to the left, forming more reactant. Disturbance ndogo tu, yani temperature au pressure, kama vitenda kuona kwa mbele, inaweza kasababisha change ya position ya chemical equilibrium. This reaction by the system is of course temporary, and eventually the system will come back to equilibrium. System inavyo move kwenda forward au kwenda backward inakuwa inatafuta equilibrium mpya. Sio kwamba ina move kwenda forward ili tu kuongeza product. No, ina find new equilibrium. So this phenomena can be expressed in the form of Le Chatelier's principle. Le Chatelier's anasemaje? Principle ni ile ambayo tulisoma form 3, Le Chatelier's principle. Kwamba this is an important and very interesting quantitative principle governing the equilibrium. Now, the principle of Le Chatelier's is named after the French chemist Henry Louis Le Chatelier's, ambaye aliishi 1850 hadi 1936, and can be stated as follows. Now, principle ni ile ya form 3, lakini hapa kuna vitu ambavyo ni kama vipi wameviweka. Wanasema hivi: if an external stress is applied to a system at equilibrium, the system will tend to react in such a way that to relieve the applied stress and tries to reestablish the equilibrium. Tukichukua stress, yani any factor, tukaiapply kwenye equilibrium system, equilibrium itashift. Na inavyo shift ina relieve the applied stress. Inaondoa, to relieve manake ni kuondoa, ina relieve the applied stress and it tries to reestablish the equilibrium. System inakuwa inajaribu kuondoa ile disturbance na kuingiza equilibrium mpya kwenye system yako. Hiyo ndo according to Le Chatelier's. So sometimes this Le Chatelier's principle can be started as we normally know in our form 3 chemistry, that if the system is at equilibrium and then any of the factors applied to the equilibrium system and alter the position of chemical equilibrium, then the system will tend to shift so as to establish the new equilibrium. Now, in a chemical reaction, terminology stress means change in concentration, pressure, volume, and temperature. When we are using terminology stress, tunakuwa tunamaanisha change ya vitu vinne: concentration, pressure, volume, au temperature. The law can also be stated if a system is in equilibrium and one of the factors involved in that equilibrium is altered, the equilibrium will shift so as to annul or to cancel the effect of the change. So shifting of the equilibrium system to the left or to the right is done in order to cancel or to annul the effect of the change. Now, let's define position of chemical equilibrium. What is the position of chemical equilibrium? Tukisema position of chemical equilibrium is defined as the direction offered by equilibrium reaction in order to maintain the equilibrium state. So tunaweza kuincrease factor fulani au kupunguza, the direction of chemical equilibrium can change. Manake inaweza kwenda forward au backward. Hiyo ndio inaita position of chemical equilibrium. Now let's start with the first factor affecting equilibrium, which is concentration. Now if we increase the concentration of reactant to the system in equilibrium, the system or reaction will proceed more forward to form the product. This is also true if the concentration of product is reduced. Our products are removed from the system. Now consider the Haber process of ammonia synthesis. In order to increase the synthesis of ammonia, we should increase concentration of nitrogen and hydrogen, or any of these. Or sometimes we should increase the pressure of nitrogen or, lakini kwa sababu nazungumzia concentration, maana inabidi to increase concentration of nitrogen na hydrogen au yoyote kati ya hizi. Our alternative way ni kuremove huyo hapa gas. Tukimremove huyo hapa tunasababisha equilibrium move more forward. If we want to produce more ammonia, we may add excess nitrogen or hydrogen. Then the forward reaction will consume more reactant, yielding more ammonia until when the equilibrium is established again. We can also remove ammonia from the system by either liquefying it or dissolving it in water. Pia tasababisha increase ya ammonia production. Lakini factor P tuangalie change in pressure and volume. Change in pressure and volume. Tunachokisema ni kwamba pressure does not have any effect on the concentration of species that are present in solid, liquid or solution form. So, on the other hand, the change in pressure affects the concentration of gases only. According to the ideal gas law, the pressure and the volume are inversely proportional to each other. The greater the pressure, the smaller the volume, and vice versa. Just enough to understand the change in pressure on the equilibrium system. Kwa pressure na volume zinakuwa zinatofautiana. Pressure inakuwa kubwa, volume inakuwa ndogo. Na volume inakuwa ndogo, pressure inakuwa kubwa. Hiyo ni according to ideal gas law ambao tutaenda kuisoma kwenye states. Lakini pia according to Boyle's law ambao tulisoma from 3 Boyle's law. So let us consider the following equilibrium reaction, which is also Haber process. Now the question is, what will happen if we increase the pressure or we decrease the volume on the system at constant temperature? We increase pressure or we decrease the volume of the system at constant temperature. Now here what we are considering is the pressure of the whole system or the volume of the whole system, not the pressure of single reactant. Kwa sababu gani? Tukisema pressure ya single reactant hapo kama ni gas, tukiongeza pressure ya nitrogen tunakuwa sasa tumeongeza concentration ya nitrogen. So pressure ya moja kama nitrogen tukiongeza maana tumeongeza concentration. So the reaction will move forward. Lakini hapa nazungumzia pressure ya system nzima. Now we are saying, in order to understand the effect of pressure, it is very important to understand the total volume of reactant and the product. According to Avogadro's law, the number of moles is directly proportional to the volume of gases. Kwa hiyo, think that 1 mole is 1 volume. Therefore, we have 4 volumes in the left on the reactant side and 2 volumes in the right on the product side. So the increase in pressure always affects the side of equilibrium position that has more volume compared with that with low volume in order to maintain equilibrium state. Kwamba increase ya pressure ina affect side with more volume as compared to the side with the low volume in order for the reaction to attain equilibrium. Now from our explanations, what you can say, hence increase in pressure shift the equilibrium from left to right. Kwa hiyo increase in pressure manake hapo itasababisha sasa ule upande wenye volume nyingi ambazo ni 4, pressure kule itaongezeka zaidi. Equilibrium ita shift kutoka left kwenda right. Now the pressure has no effect if the total volume of reactant is equal to the total volume of product as follows, such as in hydrogen iodide. Kuna mbili hydrogen iodide synthesis. Kwa hiyo tunachoweza ukisema hapo ni kwamba tukiwa kama ile na haba process, huku kuna volume 4, kwa reactant kuna 4, kwenye product kuna 3. Reaction yetu ita shift pressure, tuki increase ita shift toka kwenye volume nyingi kwenda kwenye volume chache. Pressure tuki decrease ita shift kutoka kwenye volume chache kwenda kwenye volume nyingi. Hiyo ni vice versa, kwamba tuki increase au ku decrease volume, effect inakuwa ni vice versa. Kwa hiyo kwenye hii point hapa tutaishia hapa, na in the next video tutaangalia kuhusu change in temperature na vanity of law of mobile equilibrium. Don't forget to subscribe the channel and to share the link to your fellows ili uweze kuenda kupata vipindi vya chemistry, advanced biology, physics, advanced mathematics and BAM. Thank you everybody. Nice studies.